So let's get going on section 1.5.
You already finished the whole lesson.
Now, you guys should already have these notes because that was in that packet I gave you all of chapter 1 last week. So you should already have these, but we're going to solve formulas. So the reason this is in this chapter is because really all the steps are the same. The one difference is instead of having a bunch of numbers, we're going to have letters. And remember those letters, those variables stand for numbers. So it makes it look worse because you're not used to it.
Okay.
No, it makes it look worse because you're not used to it, but it's actually easier because you don't have to simplify anything. Like if you had 7 and you subtracted 5 from both sides, you would have to simplify 7 minus 5. If you have an A and you subtract a B, you just write A minus B and you leave it and it just stays. So you don't simplify anything, you just write it down. But it looks weird, and so that's why everybody kind of gets nervous. And so hopefully we'll see. I understand, I know that it makes people nervous because it's letters, but just understand it's actually the same thing and easier because you don't have to simplify anything. I'm going to close this door. Otherwise, I get too distracted. People walk by and I want to see who they are and what they're doing.
That's something else too.
And close the back door.
We had a bat in the building, so just it was in here earlier today. We had animal control. We couldn't find it. It's back, so it's in the stairwell over there.
There's another one.
Bat or bird?
Bat.
Let us know when he's gone.
Huh?
So we just need to close all the doors and nobody gets a break.
I'm just gonna shut the door.
And you're going to chase it around?
We
I don't
can.
know what I'm gonna do.
Are you calling them again?
They only go at 5 animal control.
And they don't let
So
you touch
I
them, right?
It's after 5 when I find it, and she said.
Put a basket
It
over
was
it.
in room 5. Like I was watching all the cameras fly around. She said, just have everybody leave the room, shut the doors. And she said, just beat on the outside of the door. And she said, it'll flee. It'll find a way to get out. I go, all right.
No, it won't.
Then these rooms aren't very secure.
So anyway, I'm gonna try to put a trash can over. If you hear a scream.
If we hear screaming and running, we'll know. We'll know what's going on.
I will likely scream.
Yes.
Okay.
But just on the door side.
Do you need help? Do you need help?
No.
Are you sure?
Then she might be embarrassed. If nobody's around to see her, it won't matter what she does. If somebody's there watching.
I know Miss Rhonda. That's why I'm asking.
Yeah, she'll be there. Oh yeah, I'm helping.
I'll be here when you leave that, so just don't leave.
Okay.
The other night, I'm like, is everybody gone? I looked, the building's dark, not a single soul.
Okay.
I'm like,
I mean,
I wasn't here that night, I don't think.
it was Joel Thomas, so I called
There you
him
go.
and he's right. He's like, I had no idea. Because I might shut my door, so just
Okay.
make sure I'm gone.
Make sure you're gone. All right.
No, I won't be gone. Make sure I leave with
Okay.
okay.
All right.
For that option, we can use our notes.
Now we're going to go on to solving formulas. Now that we've taken care of the bat situation. All right. So solving formulas again.
She's gonna scream.
It's
Just so you know.
much like solving general linear equations. The steps are going to be the same. The only difference is that we're going to have several variables, and that's what I was explaining. They're going to be letters instead of having numbers. Okay, and we'll be attempting to solve for one specific variable. So when we were doing the equations, you would have an x and then a bunch of numbers. You knew I'm supposed to get this x by itself.
Mm-hmm.
Now we may have a bunch of letters, and they'll just tell you get this one by itself. And so you do the same math steps you would if it was numbers. Okay, so let's take a look. Let's remind ourselves about just equations. Okay, we're going to solve for x, right? We're going to try and get this x by itself. What math do we have to do to get that x by itself? Divide by 3, because they are multiplying, right? Or the equation is multiplying, so we've got to divide by 3. And again, with numbers, we simplify and we get 4. Okay, so that's just some review. We've already done that. That's a one-step equation. Now I want to show you this one. W times x equals z. Do you see that this is really the same thing? W times x equals z. If we're trying to get, still solve for x, if we're trying to get the x by itself, what do we have to get rid of? And you guys got really good at telling me last week what we had to get rid of. So what do we have to get rid of here? The w. And how will we get rid of it? We'll divide. on both sides. So we will divide by W, and our answer is x equals z over W. And that's it.
Because you can't do anything.
You can't do anything with it. You just leave it there. Okay? And so that's kind of the idea. It's going to look scary, but the steps are the same. Okay?
By the way, I love your videos. Thank you for recording. It just helps.
They're actually, I
Mine are
wish they
better.
were better, but I
No.
know that the sound and I know that the lights glare off the
Oh,
board
no,
and
it's
all that other
perfect.
stuff. But anyway. Okay. So let's take a look at this one. So we have m plus n equals p. And we are trying to solve for the n. This is the one we want to get by itself. So first question again, what are we going to get rid of?
M.
The m, right? Because
M.
remember, here's our boundary. So the m is on the same side. We have to get rid of it.
Mhm.
How do we get rid of it?
Subtract.
Subtract,
M from N.
right?
Mm-hmm.
Because this is a positive n. In order to get rid of it, this is a positive m. In order to get rid of it, we have to subtract m. So that will cancel. We do the same thing over here. Now our answer is going to be n equals p minus m. And we leave it right there.
Did
Okay?
you get it? Oh, okay.
Are you scooping it up with that sign?
He's already, we've got it captured in a. This is too low. Sorry, I'm so sorry to interrupt.
No, you're fine.
I thought this, we've got him captured in a trash can, and we need something to slide under it to take him.
I've done that with mice before. Get them stuck in a cup, and I have to find something to slide underneath the cup.
How big is the trash can? You want my folder?
No,
Extra credit.
he's screaming.
Extra
He's
credit.
screaming, he won't do it.
Oh, really?
Oh.
Okay,
Ugh.
who's screaming? The person there with it or the bat?
The bat.
Okay, so this time, A. We're trying to get the A by itself. Now this one is going to look complicated, but it's actually really easy. So I'm going to ask you, I'm going to do a separate problem here. Let's say that we had A times 5 equals 10. What would you do to get the A by itself?
Divide.
Divide, right? Because 5 is a number, you divide by the number. Now, I want you to think about this. We know that X is a number, correct? And Y stands for a number.
Mm-hmm.
So when you subtract them, doesn't that still stand for a number?
Yeah.
So I have A times this number, this quantity, equals B. If I want to get rid of this, we just divide by it. You can divide by that whole thing all at one time because it's all grouped together in parentheses. That's just one thing.
You don't have to
So
distribute.
you wouldn't multiply 8 times X?
No, and here's why. What happens if you multiply A times X and then A times Y? Now all of a sudden you have two A's.
Uh-huh.
You don't want to have two A's. You just want one A and you want to get it by itself. Does that make sense? So don't just, I know a lot of times with numbers we try and distribute, but really you want to keep in mind,
So
it's really this.
would it be possible though, you can add the A's together? No.
You'd have to go right back to what this is. You
Oh.
can't, with the two separate ones, you'd have to somehow get just one A, and the only way to do that is to change it back to this. So you've got to deal with this and the fact that since this is just a number, we divide by X minus Y, and X minus Y divided by X minus Y cancels to be 1, right? Something divided by itself. And we do the same thing over here. So this cancels with this to be a 1, so now we have 1A equals B over X minus Y. Just like over here, we would have divided by 5, and that would cancel that one out. You just got to remember these letters, these variables are just numbers. So when you combine them, they're still just numbers. Multiplying, adding, subtracting, they're still just going to be numbers. Okay, so like I said, it looks scarier, but isn't this step probably easier than what you guys would have tried to do if you had tried to do something else crazy? Crazy, that was mean. I mean, are you guys crazy? You're not crazy. So.
I'll be
Oh.
Okay,
I know that
Now.
it's easier.
notice what has changed. This is the next example, but notice what has changed. Has the equation changed?
No.
No, what has changed?
Solve for X.
Now we're solving for the X. Okay? And there's multiple ways to do this. But I think, okay, what do you guys think? since you guys have had practice solving and different one. Some of you guys attacked those problems, I could tell on the homework, a little bit differently, and that's fine. There are different ways to solve these. I try and go with the easiest method when I show you, but sometimes there are other methods, or there may be more complex or that turn out to be easier or whatever, but I try and keep it relatively simple.
Now, question. Now that we're talking about the homework, did it work? Did it work? That I did it like I was taking pictures of my work and then I just uploaded the pictures.
I didn't even see. Oh, actually, I think, did you miss any points?
I don't think
If you
so.
don't miss points, I don't even look at the work
Oh,
because I'm like,
okay.
well, you got it right, obviously.
Okay,
So,
okay.
but yes, I Concha did that too. And
Okay.
I was able to see hers, so I'm assuming I'd be able to see yours also.
Okay.
Okay,
Okay, slowly.
what do you think? What do you
Okay.
think we should do?
Divide by.
I would subtract. Add the y first to the other side.
Okay, we can't deal with the y first because it's trapped in the parentheses with the x. Remember how we would take off the layers? What's the outside layer here?
A
The
Okay,
a.
so we're-
How do we get rid of the a?
divided.
by eight.
Divide by the a.
Okay.
Right? You see how that's the outside layer? The x and the y are stuck together?
Yeah.
So we divide by a. And that cancels. And now, since that's all that's left, we don't need the parentheses anymore. Okay? Now what do we need? Now we're ready for the y. How do
Plus
we get?
y.
We add the y because it's a minus y, so we're going to add y. Okay. Now here's where we have to be careful. We've got the b over a, right? We can't simplify that, so it's just b over a, and then just after we put plus y, and that's it.
You don't
Okay.
cancel anything.
We can't combine it.
Okay.
If they're all different letters, we just leave them alone. Now, if you had like two a's or something, you can put those together. But if it's different letters, you just leave them alone. Okay. She's giving that one the evil stare.
I think this one.
Okay. Any questions before we go on from that? All right, now she's giving me the evil stares.
I think we're the ones that talk the most. I don't think
All
they're
these here are easy.
I don't think they're here. with
All
us.
these here are easy?
I
Okay.
mean, here it isn't, but the practice that showed in the open math is different.
What? Okay, and again, the first thing I always check, what letter are we trying to get by itself?
M.
M.
Good job.
Okay.
I keep forgetting to look at that.
You gotta look at that.
I'm
Yeah, you
already
gotta
looking
look
at the,
yeah.
okay. What's
Okay.
extra there? Okay.
Yeah. So now, which one, we have to get rid of two things. What are the two things we have to get rid of?
MX.
No, X
Oh,
and B.
sorry.
The X and the B,
Yeah.
right? Which
Uh-huh.
one are we gonna get rid of first?
The B.
The B, it's the outside layer, right? The M and the X are right together. So how do we get rid of the B?
Minus B.
Subtract B. They're adding B. To cancel it out, we subtract B. So now we have y minus b. Again, we can't do anything with that. M, x, this is gone.
Divided by
Yeah, we're trying to get the m by itself.
X.
You're going to divide. That's multiplying m times x to get rid of the x. And you are correct. We're going to divide by x. So y minus b over x equals m. Okay.
Can we do it again?
Same one?
Yeah.
Okay. I will erase this except for the circle. I'm going to leave the circle. Okay. So are we okay with the fact that we've got to get rid of the x and the b? Those are the two things we have to get rid of because they're on the same side of the equal sign as the y, or as the m. Is that okay?
Yeah.
Now again, which one is connected to the m? Or which one is grouped with the m? The x. So remember, we've got to take off the outer layers before we can get to the inner layers. So that's why we have to get rid of the b first.
Yeah. And that-
That makes sense?
Yeah.
So they're adding b, we're going to subtract b. So subtract b, to cancel that, subtract b over here. Now again, we can't do anything, it's just y minus b. And then we still have the mx over here. Okay. Now again, we're trying to get this m by itself, and you may want to circle it as you do the work on your paper just to keep in mind which one you're getting by itself. But you've got m times the x. So how do we get rid of the x? Divide. If they're multiplying, we divide. So divide by x, that will cancel. So now the m is by itself, and over here we have y minus b over x.
Okay, I think my problem was I was putting y and then
Negative y plus
negative b at the bottom.
negative b plus y.
Oh, you were putting,
I was-
because you were doing like this,
Yeah.
and you had the negative b
Yeah.
staying on the bottom?
Yeah.
Yeah, so I do that because we subtract b on both sides, just so you see it on both sides.
Yeah,
But then
I
when
just
we
wasn't-
just put it together as y minus
yeah,
b.
it makes sense now.
Okay. All right.
I'm getting sleepy.
You're getting sleepy already? We just started.
I know.
Okay, it was that sushi, wasn't it?
Yeah.
Okay. Now we're going to solve for s. So again, very important, find the s. Notice we've got to get rid of a few different things here, right? Okay. Now what's grouped with the s?
The little
So, yeah, that's symbol in there.
Yeah, it's pi. So
Okay,
those are
pi.
grouped together,
Pi.
right?
yeah.
Those are grouped together. So we're first of all going to get rid of this. Does that make sense? Because that's the one that's the outside layer.
So,
Now, we can get rid of this all at once because this and this are just numbers. So we multiply them together, they're just still numbers.
Mhm.
Okay? So it's not a 7, but you can pretend like it's a 7. How would we get rid of this if it was a 7?
minus
So you'd subtract, right? 7 from both sides. So this is just a number, so we do exactly that. We subtract pi r squared from both sides. This cancels out because anything minus itself cancels to be 0. On the left now we have a minus pi r squared. On the right we have pi r s. Okay. Now, what else do we still have to get rid of?
pi and r.
Pi and r. Notice these are all multiplied together.
Mhm.
Now, you may not remember this. This was back from the first week. But remember with multiplication, we can group things however we want to group them. Remember that? We had these parentheses and you could move the parentheses around. You're all like, that was 2 weeks ago. How am I supposed to remember that? But what we can do
Just divide
to
it.
make this easier, remember, like over here, pi times r squared was a number. Well, pi times r is a number,
Mhm.
right?
Just-
And
you're
that
gonna have to do
number-
the same thing.
That number is multiplied by s. So how would we get rid of that number?
Dividing it.
Divide by the pi r. And on this side, that number cancels with itself, right?
S.
So we've got a minus pi r squared divided by pi r equals the s. And then once that s is by itself, we know we're done. Okay, but you do have to kind of think about what's grouped together. So that's why, again, right away, the pi rs was grouped together. We had to get rid of the pi r squared first. And then once that's gone, then we can deal with this and we can get rid of the pi r. Okay, but you just got to remember, these things all just stand for numbers.
So the pi, the r, and the s, how did you like?
Group them.
Yeah, like
So-
why- if there's,
Okay, so if you remember, and again, this is back to the first week, we had a property that was called the associative property. And it basically said, I'm going to use letters just so we can kind of remember what it said. If we have a times b times c, we can group it as a times b and then times c. Or we can group it as a times b times c this way. Or we can just look at it as a times b times c. Those are all the same thing. It doesn't matter how you group when you multiply.
Okay.
That's why we switch everything to multiplication and addition, because they have those nice properties. So we just said, instead of writing as pi times r times s, we're going to group the first two, just because it's more convenient to divide by that all at one time. Okay. Is that one hard enough for you, or are the ones on MyOpenMath still harder?
What? Oh.
They're still harder? All right, let's keep trying some more then. Let's
Here's
see.
is easy.
See if we can get some harder ones. That one was easy? Is that one still easy? The one we just did? That was still easy?
It is easy, but. the
All right, you
practice
find one. You find one for me. It's so hard, and then we'll do it. It's not like I'm trying to, escape from doing a hard problem. Okay, now this one we're trying to get the m by itself.
What did you tell him that they?
We've got to get the two. What do we have to get rid of? Without me telling, I just told you. What we're trying to get the m by itself. So we have to get rid of what?
The two.
The 2 and
N.
the n, right? The 2 and the n are over here by the m. Which one should we get rid of first?
The end.
Okay, so think about which one looks like it's grouped with the m.
The two.
The 2. So let's leave it because that's grouped together. Let's get rid of the outside layer first, which is the n. And how do we get rid of? Because what is this doing? What math? What operation? Division, right? How do we get rid of that?
Multiplication.
Exactly, multiply. So we're going to multiply by n. That will cancel this. We're going to multiply over here by n also. So now we have h times n, and I'll put the times sign there, but you really don't have to put it there, just to emphasize. And then over here we have 2, and again, I'm going to put the times sign there just to emphasize. How do we finish getting that m by itself?
Divide by 2.
Divide by 2. So we find out h times n divided by 2 is equal to m. Now you may wonder, why would we ever do this? Why would we have all these letters and rearrange them?
Yeah.
The reason is because and this is kind of an application. Like if you were going to do the same math process over and over again using a formula, but you were having to rearrange that formula over and over and over again with the numbers, it'd be a lot easier to rearrange it one time and then just plug in the numbers rather than plugging the numbers and then rearranging every time you had to do the problem. So it's the reason you would use things like that. The reason you would do something like this is to, if you were going to be doing that same process over and over and over again, and you were having to rearrange it all the time. So it'd be easier to rearrange it. So for instance, if you were, just to try and figure out a simple example, if you were using the formula distance equals rate times time, okay? If you were using that formula and you knew a whole bunch of distances, so you knew this one, and you knew a whole bunch of times, and you were trying to figure out all those different rates. Well, rather than putting this number and this number in and then solving for r, and then do it again, solve for r, do it again, solve for r, do it again, solve for r, it's easier to get the r by itself right away by division. And then when you put the numbers in, you just divide, 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 and you get the answer right away rather than having to do algebra steps every time you do it. So that would be an example where you might want to rearrange a formula first so that when you put it in, you just type these into the calculator, divide, 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 and you get your answer every time just that way. So that's why, I mean, right now we're just making up letters and numbers and practicing, but that's why we would actually do this. Okay. Now this one we are solving for what? Always check. What are we solving for?
A.
A. And here is our A. And we have to get rid of the B and then the C over B, right? So think about what's your outer layer, so to speak, that we're going to get rid of first. Does it make sense? We're going to get rid of that fraction. That's the outer layer, right? Because the A over B, that's kind of grouped together as one fraction. Then you got a totally separate fraction. So we'll get rid of that totally separate fraction right here. How do we get rid of it?
No, subtract.
Yeah, they're adding. So we're going to subtract, right? So subtract C over B. Whoops, that's a D. No D in the problem, so You're doing that. So this will cancel. We've got A over B equals C minus C over B. What else do we need to do? If we're going to get, because we're trying to get the A by itself.
Multiple.
Yeah, they're dividing, right? A divided by B. So we need to multiply
By B.
by B. That will cancel this. And when we multiply over here, now here's one we have to be a little bit careful of. We haven't had to deal with this yet. But when we multiply by B, we're multiplying this whole side. Because remember, this is a number. Whatever number that is, we're multiplying that number by B. Okay? Does that make sense?
Yes.
So like if we had done this work and we had simplified C minus C over B and that turned out to be a 5, we would have to multiply the 5 times whatever this number is.
Why did you bring down the minus CD if on the top it crosses out?
This one and this one? Or this one and this one?
That one and yeah.
These two?
Yeah.
This
that
crosses out.
Crosses out, but on the bottom, the one that's in parentheses.
So that's with the C. So we've got C minus the C over B. So that one can't cancel out. So the reason it can't cancel out is because this one is, I mean, if you thought about it, it's C over 1 and this one's C over B. In order to combine those, again, that's way back to the first week also. In order to combine fractions, they have to have the same denominator, a common denominator. And so since they don't, we can't add them together. Now we could take some time and get a common denominator, but we don't need to right now, so we're just not going to worry about it. We're just worried about the algebra of trying to get these letters by themselves. Now, but what I was going to say is, right when you get to here, you should be able to stop. I think that the computer will accept this answer. If you decide not to stop, what could you do with this B? Because you guys did it a lot. In fact, Concha was trying to tell us earlier that we could do it. We could distribute the B, right? And that would be B times this, which is BC. And then it would be B times this. And this is the one that's a little bit tricky because we would have BC over B. Do you see what's going to happen with these B's? Just like, I guess I don't have it up here anymore. Yeah, they cancel. Like when we had, let's see, what we did, pi r a over pi r, and they canceled out. The same thing. If you multiply this, because it only multiplies on the top, if you multiply this, these, I just got something in my eye. These B's cancel out. And so if you do that, you're going to end up with this. But again, I'm totally okay with you leaving it like that. Or if you really want to keep going and simplify, you can do either one. But as far as what we're doing, this is far enough for me. Okay. And I noticed on the My Open Math, they've got it programmed so it'll accept all sorts of different equivalent answers. I was doing this in my college algebra class in school, and they were accepting answers that I would never accept because they're not simplified enough for my personal preference. But in this case, this is the goal, to be able to work with manipulating these variables. Was that one hard enough for you, Sally, or still easier than My Open Math?
Open math.
Open Math is still hard. Did you find one?
I mean, like the practice one, final test practice one, that is so hard.
Oh, you're talking about the review for the test.
Yeah, it's so hard.
Okay, well, pick one of those out. I'll do it. I'm not scared. I'm not scared.
Now I understand, so it's good.
Too late.
All right, so this one is a little bit different. This is the first time this has happened. What are we trying to get by itself?
B.
The B. Where is the B?
At the bottom.
It's in the denominator. This is a very, very common mistake that people make all the time. You cannot solve for a variable that is in the denominator. So you have to get it out of the denominator. And the way we do that is actually not hard, because you always do the same thing. The way we get it out of the denominator is we simply multiply by whatever that denominator is on both sides. Now look at what that does. What happens over here? If it was divided by and we multiplied,
Cancel.
it's going to cancel. So now we have 2 minus b times a equals a, capital A. So now that b is not in the denominator anymore, so now we can work with it. And there are a couple different options we have here. So I'm just going to ask you guys, what would you do next?
Multiply A. No, divide A.
Divide by a? Okay. And that's the way we kind of normally did it. Was anybody tempted to distribute the a?
Me.
Okay. And you could. In fact, I'll show you both of those ways. So let's divide first. Divide by a. Now I've got 2 minus b over capital A over little a, lowercase a. Then what would we have to do?
Plus 2.
Minus 2.
Okay, subtract. Yeah, this is a positive 2. To get rid of it, we have to subtract. Subtract 2. So this cancels. Now, here's where we have to be careful. That's still, the negative is there. Don't lose the negative. And we've got capital A over lowercase a minus 2. What's the last thing we have to get rid of now?
Divided by 1.
Yeah, we've got this negative. We're going to divide by negative 1. Now, what does dividing by negative 1 do?
Positive.
It changes the sign, right? Whatever it was, it's going to change the sign. That's what dividing by negative 1 does. So we can do this really easily, and we have to divide everything by negative 1. So this becomes b. This becomes a negative capital A over lowercase a. And then this becomes plus 2. Okay. Now, if that was your method of doing it, you're done. That's the answer. Now I want to go to you because you thought, oh, I should maybe distribute. Now let's see what happens when we distribute. This turns into 2a minus ab equals a, right?
Mm-hmm.
Then what would you do? Because we're still trying to get this b by itself.
Minus 2a.
Minus 2a. So that cancels. Okay. Then what?
Divided by a.
And let's go ahead and divide by a negative 1a right away
Uh-huh.
to get rid of the negative and the a at the same time. Okay, and I will just say, usually, again, we don't like to have this negative in the denominator. So what do? We just change all the signs. It just changes all the signs. So this would be plus, minus, plus. Okay. Now, the issue that we have, at least when we look at it kind of right away, is we're like, well, these answers are not the same. They don't look the same, right? But they are the same. What's the difference between them? And again, this is going back to the first night. Yeah, this one, we got a common denominator and we put them together. This one, we don't have a common denominator. Okay, and I don't expect you, I mean, this way is fine, that way is fine, either way is fine, but here's what we could do to show you that these are the same. Our denominator here is a, right? This one has a 1 underneath it. To get the common denominator, we have to multiply by a. And do you see now you've got negative 1a plus 2a? Uppercase and lowercase. They put a's in the same problem. That's me. Okay, and then over a would be our denominator. So it is actually the same exact answer.
Why
This-
did you put over 8 on this side?
Over a
Uh-huh.
right here,
Uh-huh.
because in order to get rid of this a, we had to divide.
Uh-huh.
So we divided. We got that. And then, are you wondering why I changed from a negative to a positive? Or
Yeah.
okay. So the reason is because when you give your answers with these variables, we don't like the denominator to be negative
Okay.
because, like, a lot of times we have to add and get a common denominator or something, and the negative just is messy.
Uh-huh.
So to get rid of that, we just change all the signs. It's the same thing as multiplying by a negative 1. So it's like we multiplied top and bottom by -1,
Uh-huh.
which is still equal to 1, because -1 divided by -1 is still 1. But that's why. Again, I think the computer would probably accept this. It's just we normally don't leave a negative there on the bottom. Or you could even put the negative out in the front. Sometimes you'll see that too. But either way. But that's just to say there will be sometimes different options you can take. And what we have done most of the time is this method, where we get rid of that A on the outside first. But if you distribute, you will still get the same answer. It doesn't matter. It may look a little bit different, but it's actually the same answer. So that's why I showed you both of those ways, is because you can do either one of those orders and still get the right answer. Okay? So now Sally's giving the evil eyes. What are you looking at? Is this one hard enough now?
I'm wondering like why A is just only under the capital A instead of the whole the whole
Okay, wait. Say that again. Or ask that again.
minus A plus 2A.
Are we over here? Or over here? Over here.
Everyone.
Okay.
So why instead of
Are you talking about right here?
Mhm.
Okay. Why is the A under the A but not under the 2?
yeah, I know that one.
Okay.
But the another step is why 2A is there? I mean like I did like separate one.
Well, these A's weren't here before.
He was just, yeah.
This was just this. So the A was still only under the capital A, the lowercase a, and the 2 was by itself. The reason I did that was to show you that this answer is actually the same as this answer. But it wasn't there before.
What about if we put like minus A by small a plus 2A? Is it okay?
Say that again so I can write it down.
B equal to negative A by A plus 2A. Is it correct?
Yeah, it's the same. So you're reducing the A.
Yeah, I got
Right.
like that.
Yeah, it's the same thing. Because that's what we said. Doing it this way, you get this right away.
Is it the same? No.
It's the same.
2A under is like 1, not A. That's different.
Oh, this one.
Yes.
Oh, no, that's not the same. Sorry, I missed it. That A can't be there. Because that A, yeah, it would have to be just a 2. Sorry, you snuck it past me, and I wasn't paying close enough attention. No, this A can't be here. Now, if it's like this, where it's under the whole thing, then that A can be there.
Is it correct? B equal to minus A by A plus 2. Is it correct?
This is correct, yes.
Okay.
And this is correct. These are actually the same, just different. It's like they've gotten a common denominator and put them together. So those are both the same.
Thank you.
You're welcome. And that's the end. Did you find a complicated one for us to do?